Hello everybody, welcome to SDN Bits. In this channel we discuss network automation and programmability concepts. And in today's video we are going to talk about zero-touch provisioning, also known as ZTP. So let's go ahead and just search ZTP so that I can show you brief information about ZTP, a definition of it. So basically ZTP, or zero-touch provisioning, is a method for automatically configuring new network devices with minimal manual intervention, allowing IT teams to quickly deploy devices like routers, switches, and firewalls by having them automatically download software updates and configuration files from the network. All right? So basically, ZTP will allow us to onboard newly installed devices into our network infrastructure in a very simple way. Okay? Let's go ahead and open the terminal and start getting our hands dirty. I'm going to zoom in so it's easy for you to see my screen. And as you can see on my terminal screen, there is a fast fetch output displaying information about my local workstation, in case you wonder, what am I using? All right, so now I'm going to switch to my lab21 directory, which is also a GitHub repository that you can clone and work on. Now, in this lab21 repo, I have multiple directories, but for this video, we're going to use Arista CUS, so I'm going to switch to Arista CUS directory and create a brand new folder. For this particular video, I'm going to call it Zero Touch, right? Cool. Now let's switch to this directory and start working. Now, to easily display what am I going to do with folders and files, I will open this directory in VS Code. So let me just do that. I'm going to open my VS Code, and as you can see, I've already opened this folder, lab21. And this is the directory, and this is the new directory we have created. So under this, we're going to obviously create our first file, which will be the topology definition file for ContainerLab, right? We're defining our lab topology. So I'm going to hit new file, and I'm going to call it ztp-lab.yaml, all right? So let's populate our topology definition file. The first element will be name. We have to give it a name, so let's call it a ZTP lab. And I am going to put a prefix with an empty string because I don't want extra characters in my host names. It makes things shorter and simpler. And now I'm going to define my topology. Topology, obviously we got nodes. So in our case, I'm just going to modify this auto-completion and call it, let's say, switch 1, right? And our kind will be COS. You can keep it as COS, or you can say Arista COS is the same thing. Both of them will work. I don't need this part, and our image is going to be COS4, and my version is 34.1F. Again, how do I know this? Go back to terminal, run docker images, and here you will see the list of images that I have. I'm going to use this image, COS, and the tag or the software version for it will be 4.34.1F. So if you have another version in your Docker engine, you will have to specify that one, obviously. This is how ContainerLab will understand what to actually deploy. Cool. This is the config for my switch 1. And now I'm going to do the same thing for, let's say, switch 2. Let's put one more switch, right? And we can even put one more, but let's just keep it simple. Let's just have 2 switches. And we are going to put a server. So let's call it ZTP server. It's going to be Linux, the kind. The image will be Alpine because it's much more lightweight. I prefer Alpine because it's just faster. Nice. Okay, so we have 3 nodes within our topology. We have switch 1, switch 2, and ZTP server. ZTP server will store the necessary configuration file for these 2 switches, right? So how our ZTP is going to work, it will basically retrieve configuration that will be within the ZTP server, within our Alpine Linux machine, not machine, but like virtual instance, and then apply it to itself in both cases, all right? Cool. So let's define the links. In our case, I want switch 1 to connect to switch 2. Maybe let's say, okay, that works. And I want obviously switch 1 to connect to ZTP server. Let's say port 5, just to make it different, right? Okay, so this is my interconnection section, and now we have to do something very important to be able to play with ZTP on ContainerLab. Now, by default, if you save this file and if you issue ContainerLab deploy commands, this lab will be deployed, but ZTP will be disabled on both of switches. And we don't want that because we cannot practice with ZTP in this case. Because by default, ContainerLab forces the switches or the devices to get a startup config, all right? But we don't need a startup config. That's an entire point of ZTP. We're trying to onboard a fresh device without any configuration on it, all right? So I'm just going to show you this very important flag that you must have. I'm going to open a new window in my browser, and I am going to head to ContainerLab's official website, which is containerlab.dev. In this website, you can go to search section and you can search for suppress, and it will show you suppress startup config under nodes. Hit this one and you will get information about this particular option. So by default, ContainerLab will create a startup config when initially creating a lab. To prevent a startup config file from being created, set the suppress startup config to true. We need this because we're running a zero-touch provisioning lab, all right? So I'm just going to copy this, and I will go back to my VS Code, and under each switch, I will add this flag. Suppress startup config, and we're going to say true because we want to suppress startup config. We don't need a startup config because our ZTP server will issue that to our devices. And exactly the same thing will go under switch 2, right? This is very important. You must do it if you want to work with ZTP on ContainerLab. All right, that's done. And to complete our topology definition file, we need a few more things to add under ZTP server. Now, I want to bind a certain folder within my zero-touch directory to the folder that will be inside our Alpine Linux, all right? So I'm going to say binds, which is another useful feature of ContainerLab. You can take advantage of, and you can find information about it on ContainerLab's official website, all right? And I'm going to create a new directory in which I will store information about our ZTP stuff, all right? So I'm going to create a new folder. I'm going to call it ZTP-data. And under this folder, I will create a file called bootstrap, all right? Now, I will talk about all these files later. So for now, let's just create a file, bootstrap. And I will create another directory under ZTP data. I will call it configs. Basically, we'll store our configurations in this directory. And let's create a simple configuration. Let's call it generic config that goes to all devices. and this generic.cfg file will contain the actual configuration we want to apply to our network devices. All right. Okay, so let's go back to our topology definition file and let's continue with the bindings. All right. So I want to bind my local ZTP data directory to my Alpine Linux. So what I'm going to do is I'm going to delete whatever autocompletion tells me, and I'm going to specify my local ZTP-data directory, and then I'm going to say colon to bind it to /var/www/ZTP directory in my Alpine Linux ZTP server, right? And I want to be to modify files in that directory as well, so I'm going to add a read-write option, all right? So this is the binding point. I will show you later on device how it looks like. And I want to execute a few commands on our ZTP server as soon as it is deployed. So I could do it manually, of course. I could connect to the shell after the deployment is completed via ContainerLab. I can do it manually, but why would I do it if I just can use this exec feature, this brilliant exec feature, and just take advantage of it, all right? So the first command I want to send is apk add -- no cache DNS mask. Now, we need DNS mask because we will need to run DHCP server for ZTP's operation. And I want Python 3 py3-pip. All right? Cool. So I want to use Python as well. That's why I'm doing this. And then I will assign an IP address directly to our ZTP server's Ethernet, let's say, 1 interface, this one here. Again, I could do it on device by running the same commands, but why would I do it if I can just directly specify it here? So every time I deploy the web, my ZTP server will be automatically provisioned with minimal configuration, right? I'm going to say IP ADDR. Now this format is for Alpine Linux. Add, let's say 192.168.101. This is going to be IP address of our Ethernet 1 interface. /24 and dev Ethernet 1, and then autocompletion already tells me what to do next. I want to enable this interface. I'm just going to hit tab, and IP link set Ethernet 1 up command will enable our newly created interface. All right. So this is enough, and I'm also going to enable our DNS mask process by basically hitting DNS, just typing DNS mask here. All right, cool. So this should be enough for now. The rest will be shown on the device itself. Now I'm going to save my topology definition file because I think it is ready. We have the links. All right, we have the nodes. Again, we will have 2 switches without any configuration. And we'll have one ZTP server which will store configurations in it, in generic.cfg file, and which will also contain bootstrap file that will go to the device and guide the device to a fetch ZTP config and apply it to it itself. All right, cool. So now let's go ahead and populate our bootstrap file. Now, in order to get configuration from ZTP server, device must send a get operation to the ZTP server by taking advantage of HTTP. All right. So here's what we're gonna do. First of all, we want to make sure that device is able to run this bootstrap script. And to be able to do that, we need to specify a shebang line saying to the device that, hey, this is a file that must be executed using Python 3. So to do this, we're going to add a shebang line, and it goes like this. You can read about shebang separately if you want. And I'm going to say Python 3. Okay. And then, because we are going to use HTTP protocol to get necessary information from the HTTP server that will be inside our ZTP server, we need to take advantage of Python's requests library that can work alongside HTTP, right? So I'm going to import requests library. Perfect. Now, I want to create a variable which will basically store the URL to our configuration file. I will call it config URL, sub variable, again nothing fancy, and I'm going to say HTTP, a basic URL syntax. I'm going to specify the IP address of my Ethernet 1 interface on ZTP server, which was 100.1, as you may recall. I want to take advantage of port 8080, which is an additional port for HTTP, and I want to specify where is my configuration file located, which is generic.cfj under configs directory. All right, perfect, ready. I will put a basic message saying that, hey, I'm trying to fetch configuration from this URL, okay? Just to track the progress when script is getting executed, all right? Okay, so let's say actually ZTP, we can add like something like this, fetching configuration from this URL. And now, in principle, it should work, and after it does, right, we should have the configuration. But how do we actually get the configuration? So this is the part. We're going to create another variable, we'll call it response, and we'll take advantage of requests library here and use HTTP protocol to get our device configuration. We're going to say requests.get, and we're going to specify the URL that we want to connect to. So this will establish an HTTP session to this server, to our server, with this IP address, with this port, and it will find this particular directory which stores our generic configuration. Now we need to put some conditions in here because things might go wrong, all right? So we're going to say if response, the variable that we created which stores our output, the status code is 200. 200 basically means that HTTP session was established successfully and we got the response we wanted. All right? So if we got the successful response, all right, we are going to create a file in our mnt flash directory, and we're basically going to name it startup.config, and we're going to actually overwrite the existing startup.config file that will already be in the device, right? Or will be in the device after our ZTP process. So we're opening this file. As you can see, we're saving it as config file, and then we're opening it, and then we're writing the text of that response. So we'll get some response, and that response will have a header, a body. We need a body because that's where we have our payload or our actual configuration. And we're basically going to add this to this file, which is located in device's mnt flash directory. All right, and this is how the device will automatically configure itself. Cool. So I'm going to just put a simple message that ZTP configuration applies successfully, else ZTP failed to fetch configuration, status code, and we're basically putting a, sorry, it did not autocomplete correctly. Yeah. yeah, it's basically going to say failed to fetch configuration, blah, 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 status code, whatever status code we get. We might get any status code way from 400, 404, not found, and anything like that, all right? So this is our bootstrap file. I'm going to save it, and this should be enough. We don't have to do anything else yet. If I'm not mistaken, this should be enough for ZTP to work. And now we're going to create an actual configuration that we want to apply to devices. So I'm going to create a very basic config snippet that will be applied to our device. I'm going to give it a host name. Let's call it ZTP device, right? ZTP device. And I want to give it some credentials. Let's say secret admin as well, just like ContainerLab does it. Nothing different. Then let's say spanning tree mod none, because I want to capture some packets and I don't want spanning tree frames to basically occupy my Wireshark packet capture output. And I am going to configure interface Ethernet 1 on both switches. And let's say, yeah, let's just say interface Ethernet 1. Let's say, no, we don't need to say shutdown. Let's just say description. Let's just add description. Nothing fancy. Description going to be ZTP server, right? ZTP server. This is the description. Again, nothing fancy. And let's add a simple banner message and say this device was provisioned via ZTP. Provisioned. Yeah, provisioned by zero touch provisioning. Okay, looks good. And perfect. So now this is going to be our basic generic configuration file that will be applied to both switches using ZTP, right? So cool. So now we can actually go back and check if we have everything. In principle, we do. Again, we have our binding feature that binds our ZTP data folder to our Alpine Linux folder var www.ztp. And we have a set of commands that will be executed upon device deployment and will basically make our server ready, except for the DHCP configuration that we can do later on the device. But in principle, I'm thinking we could do it even now, actually. We can add another binding that says basically, okay, let's actually try that. Let's actually create a new file that is going to be our DNS mask configuration, or let's say DHCP config that we need for our device. And I'm going to create another binding here. I will say, so this folder, sorry, don't bootstrap, what was that? DNS mask conf, right? Yeah, cool. So dnsmask.conf, bind it to etc dnsmask.conf inside the ZTP server. That's great. That's exactly what I wanted. And now we can save this, all right? And we can already put our DHCP configuration here. So for DHCP configuration, we're basically going to specify the interface we want to use. It's going to be Ethernet 1, because that is the, Ethernet 1. We don't need to do it as VS Code suggests. Yeah, this interface. All right. And I am going to add a DHCP range, let's say 192.168.100. Let's say 20 and I will put comma, and I will specify the end range. 168, 100, 30, and I'm gonna lease it for, let's say, 12 hours leasing time. So I'm gonna add DHCP options now, basically specifying what's the default gateway address, what's the DNS server address, and I will do it by using DHCP-options flag, right? DHCP options, yeah, 3, and we're specifying the default gateway, which is again our Ethernet 1 interface on ZTP server. Another DHCP options for DNS will be option 6. It's going to be Google's 8888, just to keep things simple. And now we're going to specify the most important DHCP option for ZTP. It's going to be DHCP option. By the way, I have a typo here. I just realized that, and I don't think we need S. Sorry about this here. Option, DHCP option, dash option. We're gonna call it 67. DHCP option 67 is vital for ZTP's operation because it will tell the device where to retrieve ZTP boot file, all right? And now I'm gonna specify the URL to our bootstrap file that is needed by device to execute ZTP operation. Of course, I'm going to specify the IP address, then the port, which is 8080, and then the actual file, which is bootstrap. All right? Cool. Now, we're going to enable HTTP server from a directory which already contains this file, so we don't have to indicate the path. All right? Cool. And I'm going to add a few more options for logging DHCP messages so that we can basically, control, monitor the logs to see how it's going, right? Cool. So now our DNS mask configuration is ready as well. Now in principle, as soon as I deploy this lab, right, switch 1 and 2 must be basically deployed with no configuration. ZTP must be enabled on them. We'll verify it via CLI later. And ZTP server must already contain ZTP data folder and dnsmask.conf file in it and already execute this command. So we already should see an Ethernet 1 interface up and running with this IP address on our ZTP server. All right? Cool. So this is the most interesting part of our video. We are going to deploy this lab on ContainerLab and play with ZTP. So I'm going to open up my terminal again. I'm just going to show you the folder structure for what's going on here. We have our DHCP configuration. Again, this will be on the ZTP server. We have our ZTP data folder, which contains a bootstrap script, which will be executed by our switches. And we have a configs directory, which contains our generic config file, which basically contains a configuration that will be applied to the devices. And then we just have our ztp-web.yaml file, which is topology definition file necessary for ContainerLab to deploy the web. Okay, let's go ahead and say clab deploy -t ztp-web YAML and hit enter. Okay, now ContainerLab is deploying the lab. It can take a few seconds. We have only 2 switches running Arista CEOS, and we have a simple Alpine Linux server. Now, I named it ZTP server, but essentially you must understand that ZTP is not an actual service that is running on the server. On the server, we will have a DHCP process under DNS mask, and we'll have an HTTP server service. So that's what you need to understand. I'm going to actually show you. So now our lab has successfully been deployed, but we have one issue here because of my stupid mistake and the typo that I made. So let me just show you what it is. I had to, IP other. We have extra letter here, so I'm just going to save it with this. So I will need to do it myself. It happens. What the hell? So let me open a new tab, and I am going to open a shell session to our ZTP server. And as you can see, our Ethernet one is not configured because of my typo, so I'm going to do it manually. No, this is not what I want. Again. Yes. And now we can do the rest, which is this command. I'm going to go back, paste it, and say PSA. Yeah. So now if I say IPA, our interface has been configured with the necessary IP address and it's up and running. And as you can see by PSA output, our DNS mask server service is also running our process. So it means devices should already get a DHCP, an IP address via DHCP. So let's go to one of our devices. Let's say switch 1. All right. So I'm going to open a CLI session to switch 1. So docker exec-it switch 1 and CLI C with capital, enter. Yeah, cool. So this is our device. As you can see, it doesn't have any host name because of our suppress startup config flag. And I want to show you something very important. Show zero touch command will show you ZTP state. As you can see, at the moment it's active. Now, if you did not specify this option, suppress startup config, then by default you would have zero touch mode disabled, not active. All right. So what is happening now, right? We have to confirm one more thing. I just want to make sure our bindings are there. So I'm going to say cat etc dnsmask.conf. Yeah, as you can see, our binding for DHCP dnsmask.conf file has been applied successfully, and let's see if the same is true for the other binding that we had for our ZTP data folder. So I'm going to go to var ZTP directory, and I'm going to say lsltra, and as you can see, we have everything that we need in here. We have the configs directory, right, and we have our bootstrap script. So this basically means we just verified that this part of the topology definition file did its job real good. Cool. So now what's going on, right? We have our DHCP server running, and let's confirm that our devices actually can get an IP address. So show interfaces description. We currently have two interfaces on switch 1. Ethernet 5 is going to the ZTP server, and Ethernet 1 is going to the other switch, switch 2. And let's see if Ethernet 5 gets an IP address via DHCP. So I'm going to say show interfaces Ethernet 5. And as you can see, we have successfully retrieved an IP address from DHCP server on our Alpine Linux ZTP server. And this is our IP address for now, .21. So now we have an IP address, but device is not configured via ZTP. Why? Because we have not enabled HTTP server. At this very moment, device is trying to get into the HTTP server to fetch the file, right? But it can't. To demonstrate this, I'm going to run show logging follow command, which basically shows you all the logs in real time for Arista EOS platform. I'm going to hit enter, and as you can see, we have a lot of ZTP logs here. So if we take a look what's going on in here, it's trying to do a few things. It's trying to attempt to download startup config from here, right, from the bootstrap. And it is failing to do so because it cannot connect a server. And it cannot connect a server because we have not enabled HTTP server. I did it on purpose just to show you what's going on the device. So in real life scenario, when you as a network engineer must provision a fresh device, okay, so usually a data center technician will install your box to the rack and then power it on and then connect the necessary cables. And as soon as device powers on, with the cables on it, all the devices come with ZTP enabled, and they are trying exactly the same process. They are trying to look for a ZTP server that provides them a configuration file or a software image to upgrade or downgrade or whatever. But this is a default behavior for most of modern networking equipment. All right? Cool. So I am also going to show you what's happening in a packet level, right? So I am going to open our ContainerLab extension for VS Code. First, I will show the topology. This is our ZTP server. This is our switch 1. This is our switch 2. So our ZTP server should supply a configuration file to switch 1 and switch 2 through switch 1. But at this point, we have a DHCP server running here, which already assigned an IP address to this guy, this Ethernet 5 interface. And using that IP address, it tries to get into the HTTP server here and retrieve the generic config, right? So if we actually inspect packets in switch 1's Ethernet interface 5, let's open it up, we will see that there will be lots of DHCP exchanges to get what it wants. So let's give it a few seconds. Okay, as you can see, we got a DHCP offer from the server, which is our ZTP servers 100.1, and .21 is our switch 1. It requests this IP address, and then it gives it by acknowledging. So we can actually just take a like deeper look. We can open the actual packet, and here you will have obviously the layer 2, layer 3, layer 4, and layer 7 information on the YSI model. So interesting things to note. For example, we're using UDP, source port 67, which means DHCP server, and destination port 68 means DHCP client. And if we open the layer 7 packet, which is DHCP in this case, we'll see that, for example, DHCP has already acknowledged that this IP address .21 is going to be yours, which is switch 1, right? But then, if we scroll down, we'll see more information is being basically relayed here to our switch 1. It provides, for example, itself as a DHCP server. This is me. This is your default gateway and server. IP address release time. Remember, we configured 12 hours. You can actually see it here. You got the subnet mask. You got the broadcast address, DNS server, which is going to be 8. Because that's how we configure it again. But most importantly, this magic option 67. If we maximize this, this is exactly the boot file name's URL here that we specified again. So this is the vital thing for ZTP's operation. So far, everything is good. All right, DHCP does what it needs to do. It is trying to take advantage of option 67 for ZTP and actually point to a right URL for device to retrieve configuration from. Now, we are going to go back, right? I'm going to close this packet. And if you continue inspecting, you will see that this will go on forever. Then the DHCP will release the address, and then new transaction will begin with new ID, and then again the same thing. We get discover, and then ZTP server will offer the IP address, and then for request to take that, and server will acknowledge. Okay, then RF will try to find something else needed for ZTP's operation. Some TCP sessions will be tried, but will be reset. Why they will be reset? Because again, we cannot connect to the, we cannot connect to the server, and we'll reset the session every time because server is unreachable, all right? Because it basically doesn't really exist. It's not enabled yet, right? And this will go on forever. If you actually inspect, this is the behavior that your devices in real life will have when they just have been installed and powered on, but they don't have a ZTP server that has HTTPS server enabled in it. Now, since I have shown you this part, we're going to go back and enable HTTP server and see what's going on. All right. So to enable HTTP server, all we have to do is go to this directory, which we just created, which basically consists of our context directory and bootstrap file, and enable HTTP server in this directory. All right. So that's exactly what I'm going to do. I'm going to say python 3 -m, and I am going to specify the HTTP server to enable it as a service, as a process, and I'm going to say the port that we need, which is 8080 because this is how we configured it, and hit ampersand and enter. So as soon as I do this, in principle, what will happen is this switch will attempt again to download this bootstrap file, and it will succeed downloading it, and it will go offline for a few seconds. It will apply the config in generic.cfg file and come back with an applied config, and that will mark our ZTP successful operation. Now we might see some errors, maybe I have configured something wrong, but we will see it in a few seconds. I just really want you to understand what's going on behind the scenes. That's why I take so much time to explain. And I'm going to hit enter, and as soon as I hit enter, as you can see, now we're serving, now our HTTP service is running. So if you go to device logs, let's see what's going to happen now. Retrying, sending DHCP request to option 67. We're going to wait. We're going to wait. Okay. We got some DHCP information. We got the IP address. We got the DNS server. Aha! So there you go. This is the part that I really wanted to show you. So what happened is, yeah, there you go. We got our DHCP stuff. This is the part. We got our IP address, our DNS server, our gateway, and the boot file. This was happening already with so far. But now, instead of saying config download fail, we see config download attempting to download startup config from here, from this URL, and ZTP config download success. Successfully download config script from this URL, and now it's going to execute the download config script. It's basically using the shebang line that we have specified here. Let me actually show you guys, because this is very important to understand. All right, I'm going to go back to my file. We'll go back to packet capture again. There's a lot of interesting things happening there. Sorry about this. Where was this? Yeah. It's going to execute this script using this shebang line, right? This is the part that's doing it. And then it's successfully executed the download config script, and it's going to reboot the system because it applies configuration for itself. All right? And it stops all the processes, it shuts it down. As you can see, all processes have stopped. And now we're going to reconnect to the same switch, switch 1, And in principle, we should see a new host name of ZTP device. And yes, there you go. ZTP device. So now our device is provisioned by ZTP. I'm going to enable, I'm going to say show run. As you can see, we have our host name. All right. We have the description that we configured for ZTP server. And we have our username, admin, privilege configuration. Yeah, so user configuration basically. So, and we also have obviously our spanning tree mode non-config. So I disabled spanning tree. Now let's go to switch 2 and see if it took the same config. I'm going to open a new tab. I'm going to say docker exec-it switch 2 CLI. And again, yeah, same thing happened here. So show run. So both switches were provisioned via ZTP. Right? Again, spanning tree mode none, hostname ZTP device, description is the same. Perfect. This is exactly what we wanted to achieve, all right? Now, and if you go back to actually the ZTP server, you will see that because we enabled logs, we can see that there are 2 attempts to get Bootstrap. One attempt was from this IP address, which is our switch 1, and it got what it wanted, which was Bootstrap first, and then Bootstrap executed successfully and got the config. All right? Got the config, generic config. And the same thing happened for another device, which has this IP address for 26, which is our switch 2. So to confirm this, I'm just going to run show interfaces Ethernet, one command. Yeah, actually it's not going to show the IP address because again we have already provisioned the device via ZTP, and this is a switch port interface, so that's why it automatically deleted ZTP assigned IP address, and it also in principle should disable ZTP process. So because it reloaded itself, so let's say show zero touch, and guys, as you can see, zero touch mode is now disabled. Why? Because it already provisioned itself via ZTP, it reloaded the switch, and it does not need it anymore. To avoid any confusion, it disables ZTP, all right? Cool. So this is what we wanted to achieve here, and we successfully achieved. Now, for the last bit of this video, because it's already quite long, I am going to show you exactly what happened on packet level. So we're going to go to VS Code and open the switch 1's Ethernet 5 packet capture interface. And if we go up, so basically we already talked about this part. DHCP is process is running, getting some IP, then it's going to release that IP address, right? And then it's going to try again. TCP is going to fail because HTTP server is not enabled. There is no session to be established, and session will be reset, blah, blah, blah. The same thing goes until we actually enable the ZTP server's HTTP server process. And now DHCP does exactly the same thing. Discover, offer, request, act, DORA process runs in here. ARP does its thing, finds in whatever it needs to find, populates the ARP cache, all right. And TCP establishes a session. So this is TCP synchronized, right? So we're sending a SYN flag, all right. There you go, we have a SYN flag set to 1. We're establishing a session with this destination port, 8080, in this IP address, 101. So we're establishing a session to ZTP servers, port 8080, all right. What happens after is we're getting acknowledgement from the server. As you can see, the source is server's IP. We're getting an acknowledgement. So if you open this, you will see that there's SYN, all right, and it's connection establish acknowledge message, SYN ACK, from server port 8080, all right. So this is our TCP session. So first we're getting, again, first we're getting IP address, then we're establishing layer 3, we're populating ARP caches, right? And then we're establishing a layer 4 TCP session. And now, since we already got our acknowledgement from the server, as you can see, this acknowledgement bit is set to 1, we can begin to do things at layer 7 of OSI model. And now we're going to take advantage of HTTP because we're running an HTTP server. And if we open this packet, if we inspect it, I'm going to open this. Again, the same thing, guys. We have our source MAC address, destination MAC. We have our source IP address, which is switch 1, destination ZTP server, and then TCP layer 4 session, random port on the switch side, 8080, port 8080 for HTTP on the server side. All right. So we get acknowledgement, flag set to 1, and now we're trying to send something. So there's also push flag set to 1. And if you go down, we'll have our layer 7 information, which is HTTP. I'm going to maximize this, and the most interesting things are happening in here. So we're sending a GET request, all right? Now, how does it work, the GET request? Do you see? Get bootstrap. We want to get bootstrap. So this is, I'm going to show you which part is it. Actually, it's right here. We're in this part. So this script now has been downloaded by switch 1 and switch 2. It is located in there, and switches one by one execute the script in their bash shell, and they are using Python to execute the script, and they are taking advantage of request library to send a GET request to this URL to get configuration, right? To get bootstrap first, sorry. Bootstrap first and then configuration. So go back. We're trying to get bootstrap. This is the host's IP, which is our server. And it also advertises its MAC address, its model name, its serial number, because you can use ZTP by using devices, basically MAC address or a serial number, depending on whatever you're referring to. So for in real life scenario, you might have a net box, and DC technicians, after powering on your fresh devices, they will populate the net box entries for serial number, for example, and the ZTP server might retrieve that from there and, you know, provision your device accordingly. So then you have secure ZTP false. It's a different mode of ZTP which can be used for troubleshooting or diagnostic purposes. It's disabled, which is expected because this is the default behavior. It advertises its software version and the architecture. And again, you can see the full request URI. Do you see the link? Yeah, this is the link we specified under DHCP option 67. All right, cool. And we got some response in frame. So it retrieves, it's trying to retrieve, it's establishing a session to retrieve the bootstrap first. All right, so just to confirm where yeah, this was the packet we just looked, and then we got a response from HTTP server saying that session was established successfully. So 200 OK status code. It means great. I understand what you want. I got your bootstrap file, all right, and it is basically going to give it the bootstrap. If you maximize this data part, and if you come in here, you will see the actual content of our bootstrap script. Look at this. Check this out. Do you see? This is the shebang line, user being env Python 3, then we import. We're seeing an actual content. This data section shows an actual content of the bootstrap script. Now, why we can see it like this? Is it normal that we can see it on Wireshark just like this? Absolutely not. The reason why we see it, because we're using HTTP protocol, all right? Not HTTPS, not the secure version of HTTP. Now, this is exactly why in production environment, you must use HTTPS, because HTTPS will encrypt this data part so that any interceptor or any person with malicious intent cannot capture your packets just like this and read the data in plain text just like this. This is not normal, but because this is a lab, it's a simple lab scenario, we don't care about security here, we use HTTP. But normally in production networks you must use HTTPS. Alright, so this is actually pretty cool that we can actually see everything here. And there's a lot of information in this obviously packet, but I'm just trying to show you the most important bits, right? Says code description okay, and now I'm going to close this packet again, sorry. So now we got the bootstrap, but now we have to execute. So in the meantime, after this OK operation, in this time frame, as you can see, it's going to terminate the session with HTTP server. If you can see the fin means finish, right? It's going to terminate, it's going to gracefully terminate the session with the HTTP server, and then it will establish a new session. So between these two packets, all right, device executes bootstrap script in its own bash shell, and within that script there is another GET request that forces device to establish a new TCP session to our ZTP server. Which one is it? This one. So now device executed this part and it's trying to send another GET request to get this file, the generic.cfj, and because of that, basically we're seeing another TCP session just after the fin. You will see another ACK is coming up. So sorry, this ACK is actually to finish the session from the server side. So here we request to finish the connection, and then server acknowledges yes, okay, let's finish this session, and then after script is being executed, so it was between packets 193 and 194, we are trying to establish a new session. Again, SYN ACK, all right, and ACK. So TCP three-way handshake successful, and now HTTP comes into play using active TCP session. It is sending another GET request. Now this time we are trying to get something else. This time we're trying to get the config. As you can see under configs directory, generic.cfg file, which stores an actual configuration we need to apply for the devices. So that's what I want now, says our switch 1, and sends this to GET request to the HTTP server within our ZTP server, and request method GET. This is the URI. This is the host, and which is our server, obviously. We're using Python's requests library. We can absolutely see everything in Wireshark. This is so amazing and so cool, right? And then obviously we have the encoding, how I want to accept my data and everything. And we got response 201, all right? Which means, yeah, you got what you wanted. We have what you wanted, sorry, yeah. So then we are going to close this packet and see what's going on again. There's another acknowledgement, another push. Now we're using TCP push flag again to push something, all right, which is our data. And now we have another successful awk request. I'm going to open this packet. Again, the same thing. We have layer 2, layer 3, layer 4, layer. We have the push flag set to 1, so we're actually pushing some data to the device that wanted it. And now if you go down again to the layer 7 section, which is HTTP in this case, we got a successful request, successful response, which is 200, all right? And you can see it here, so let's go 200, right here. And if you go down, if you scroll down more, you will see more information. And again, you will have this additional data section, which is basically a body of your HTTP message, which contains an actual data that is stored in this file, in generic.cfj. And we actually can see, if you hit on this, you will see in this part, we have the config. Look at this, hostname, ZTP device, username, admin privilege secret, secret admin. You see? This part, we actually can see the configuration of switch 1 and switch 2 in Wireshark captured in plain text. So if you run this in production, if there is anybody who is running Wireshark to capture packets of your links, flowing in your links, they will actually get this information effortlessly, which is exactly why, again, you must use HTTPS in production network. But again, just to demonstrate, this is how it looks like, this data. So this data, right, it's this part. It's the response.txt. If you remember from our Bootstrap script, it's here. Okay, response is header, but text, this text option here is this part, guys. This data part, it corresponds to the text part on the script. All right, cool. So now that configuration is successfully received from ZTP server, it will apply. So after this operation, device is applying it to itself, and then it will do the same thing, and then it will terminate the session gracefully, and then TCP session will be closed. So we don't need any more. Then there's another DHCP coming up, another ARP, but this time we have a different source IP. The same thing is happening with switch 2. Now switch 2 will do the same thing. It will basically send a get operation to get Bootstrap script. Server will deliver that script. It will finish the session. It will execute the script in the meantime, right? And then it will create a new session, new TCP session towards ZTP server. And now it will request the configuration. Server will provide the configuration, and it will terminate the session again gracefully. It will apply it to itself, and now after that, as you can see, there is no more DHCP, no more TCP, no more HTTP sessions needed, because ZTP successfully completed its operation, and it's no longer needed. We only have LDP frames and sometimes ICMPv6, but that's pretty much it, right? So that's basically it, guys. This is how ZTP works. Now, I suggest you to clone my repo and run this on your local workstation, deploy this web using ContainerLab, go to the packet capture, analyze the packets, inspect the packets, see what's going on, look at the source, look at the destination, all right, and then play with it if you really want to understand what's going on. So you can take advantage of any scripts that I have pushed to my repo, right? You can just do whatever you want. You can play with it. You can play with other DHCP options. You can actually make a more advanced script. Again, I made a very simple script for demonstration purposes, but obviously you can make a script which is much more sophisticated than this one with try exception blocks and everything. We can make a configuration which is, you know, which contains pretty much everything you need for your generic for your devices to run. You can put 50 devices here. You can put 50 switches, right? You can say switch 1 to switch 50, and then all 50 of them will use ZTP to get the generic config. So this is the beauty of ZTP, right? It facilitates the onboarding, initial provisioning of devices in your network. Now, this is a ContainerLab demonstration, so in principle, if we had a hardware lab, I could also show you how to add software images. So in principle, we could also store a software image in our server, and our switches could, in principle, retrieve that software image and upgrade themselves accordingly. So you can do a lot of things here, but this is a very basic video which illustrated how to run this using ContainerLab, Arista CUIS, all right, and configure your device using ZTP. And again, just you can play with it as you want, all right. For now, I would say that's it. This video has already been longer than 1 hour, but I believe we have covered a lot of interesting points. In this video, we created a topology definition file from scratch. We have created a bootstrap script. We have created a configuration storage, and then we used ContainerLab's bind feature to bind our directory in our local workstation to the Alpine Linux one. Let me actually again just show you what I'm talking about. I'm talking about this part. We executed some scripts. We used DNS mask process to run a DHCP server, and then in this DHCP server we identified the option 67, which is necessary for ZTP's operation, all right, and then we actually made our devices to retrieve configuration and apply to themselves so that they are provisioned via ZTP. So this is basically it for today, guys. Thank you very much for watching this video, and in the next videos we can take this to the next level and actually talk about more advanced ZTP scenarios. But for now, I really hope it was useful and insightful. If you have any questions, please don't hesitate to ask on the comment section, and see you in the next video.